Have you ever pondered what makes a number irrational or transcendental? It's a question that might seem daunting, but today we're going to dive into the intriguing world of irrational and transcendental numbers. Let's start with irrational numbers. These are numbers that cannot be expressed as a fraction of two integers. Picture the number pi or pi and the square root of 2. These are both examples of irrational numbers. They're called irrational because they cannot be expressed as a ratio of two integers, hence the name. Now let's shift gears and talk about transcendental numbers. These are numbers that are not algebraic, meaning they cannot be the root of a polynomial equation with rational coefficients. Pi again is a great example here, as is the natural number e. But what makes a number transcendental? It's the fact that it can't be the solution to any polynomial equation with rational coefficients. It is important to note that all transcendental numbers are irrational, but not all irrational numbers are transcendental. Let's take the square root of 2 as an example. It's an irrational number, but it's also an algebraic number because it is the root of the polynomial equation x squared minus 2 equals 0. Transcendental numbers are a fascinating subset of the real numbers. They are uncountably infinite and cannot be constructed using rational numbers and basic arithmetic operations. You'll find them popping up in many areas of mathematics, including number theory, analysis, and geometry. Some examples include the golden ratio, the Chaitin constant, and the Catalan constant. The study of transcendental numbers is a challenging and active area of mathematical research. Mathematicians are still working to prove that certain numbers are transcendental and to discover new properties of transcendental numbers. To summarize, we've explored the concepts of irrational and transcendental numbers. We've learned that irrational numbers cannot be expressed as a fraction of two integers, and transcendental numbers cannot be the root of a polynomial equation with rational coefficients. All transcendental numbers are irrational, but not all irrational numbers are transcendental. These complex concepts are fundamental to the field of mathematics, and understanding them will open up a whole new world of mathematical exploration. So, the next time you find yourself looking at a number and wondering about its nature, remember, it could be irrational, it could be transcendental, or it could be both. The world of numbers is vast and fascinating, full of mysteries waiting to be discovered.